All right, we're doing Module 5, Lesson 17. We're going to start to compare two populations using sampling. So before we begin this lesson, I have to remind you about this graph. This is called a box plot or a box and whisker plot. Now, you should have learned this in 6th grade, but we're going to talk about this again. So here's what this looks like. This is called a box plot. All outliers are going to be using a star to represent an outlier. An outlier is a point that is an extreme value. A lower extreme is where you just place a dot at the lowest number, not including the outliers. The lower quartile. The median is the middle of the box. The upper quartile and the upper extreme, that's going to be the highest number. Now, even though the parts may be different in length, see how this is a lot longer than this, that each section still contains 25% of the data. So 25% of the data is here, 25 is here, 25 is here, and 25 is here. So that means that the same amount of points are in each section. This just may be a little bit closer together than this section. So let's look at this graph right here. It says we're going to state the lower quartile, the median, the upper quartile, the range, and the interquartile range. So the lower quartile, we also call that the 25th percentile, or Q1, is going to be 30. That's at the left side of the box. The median, which is the 50th percentile, or Q2, is 40. Remember, that's the line right here. The upper quartile is the right-hand side of the box. This case would be 60. Now, range means the lowest number, or the highest number minus the lowest number. So this would be 70 minus 15, which would be 55. Now, the interquartile range is Q3, which is 60, minus Q1, which is 30. So 60 minus 30 is 30. There are no outliers. There's no asterisks or stars in this case. All right, so now that we can read, let's start to compare. So in this case, we have two sets of data here. Actually, I believe they're the same sets of data, just shown as a box plot and as a dot plot. So what are some of the similarities here? Well, it ranges from 6 to 19. So their ranges are the same. Now, the difference is we can only, from the box plot, we can only find the median. We cannot find the average or the mode because we don't have the actual dots. Whereas in the dot plot, you can see the mode is 10 most often. You could actually calculate the mean. So which graph do you think is more descriptive? Well, you can tell a little bit more from the dot plot because you can find the mean, median, and mode. You can find the range in both of them because you can just subtract the highest minus the lowest. I would say the dot plot, though, just because you can see the data points, gives you a little bit more description of, the actual data. So let's take a look at something called extreme values. So the number of songs downloaded during 1 week are shown in this table. Which measure is most affected by Saturday's downloaded? Now, what that means is look at this chart. We have 5, 2, 3, 0, 6, 4, real low numbers, and all of a sudden on Saturday we get to a 36. So we would call that an extreme value. So does that extreme value affect the mean, the median, or the mode? Well, let's calculate all of those measures of center and see which one it affects the most. So let's start with mean. We're going to do it with Saturday's downloads. So the mean would be 5, 2, 3, 0, 6, 4, and 36. So add them all up. You can take your calculator to do that. I got 56. Now I'm going to divide 56 by 7, and you get 8 songs per day. Now, the median, remember to find the median, you're going to line them up from least to greatest. So 0, 2, 3, 4, 5, 6, 36. And you're going to find the center number. So 0 and 36, 2 and 6, 3 and 5. So the middle number is 4. Now, the mode is the one that happens most often. There is no mode in this because there's none that happens more than once. All right, so let's do it without Saturday's downloads. So we're not going to include 36. So 5 plus 2 plus 3 plus 0 plus 6 plus 4. Go ahead and add those in your calculator, and you get 20. 20 divided by, oh, we're dividing by 6, not 7. 20 divided by 6 gives us 3.3 repeating. Now, the median, we're going to line them up, 0, 2, 3, 4, 5, 6. So 6 and 0, 5 and 2. Now we have two numbers here. When you have two numbers, you're going to take the average of them. So 7 divided by 2 is 3.5. And there's still no mode. So this extreme value here, what does it affect? Well, look at how much difference there is just in the average. The median is very, very similar still, and the mode is still no mode. So the mean is what the extreme values affects the most. It really pulls that average in one direction or the other. But if you look at this, there's not many numbers around 8, so that's really deceiving if you use that extreme value. So when would we use mean, median, or mode to represent our data? Well, if the data has no extreme values, then mean would be the best, finding the average. If a lot of the data points are all around the same spot, that would be no extreme values. That's when you would use mean. The data set has extreme values, and there are no big gaps in the middle of the data. That would be the median, would be the best way to represent your data. And if it has a lot of identical numbers, that's when you would want to use mode, because mode is most often, the number that is included most often. All right, that's all we're going to do. Your problem set is actually the second page of the problem set, not the first one. The first one we're going to do on day 2 of this lesson. Have a good day.